So next we're going to talk about the conditional statement and variations on that conditional statement. Now we've already talked about the conditional statement being if P then Q, and we're going to write that out. If P then Q. The converse is a variation of the conditional statement, which just takes the P and the Q and switches places. So the way we pronounce that would be if Q, then P. Now, when I switch it around, that's not actually the same statement anymore. It's a different statement, so you can't call it the same conditional statement, but we can call it the converse of the original conditional statement. Our next one is the inverse. The inverse negates the P and the Q, but keeps them in the same order. The way we pronounce that would be if not P, then not Q. And that is called the inverse. And then the last one is the contrapositive. It both switches the P and the Q's spots, and it also negates them. The way we would pronounce that is if not Q, then not P. So each of these is a different statement, but we want to investigate the truth values for each of these combinations. So I have two statements, P and Q, and I want to investigate. So let's do the conditional first, which is if P then Q. Remember, the rule is it's only false when P, the antecedent, is true, and Q, the consequent, is false. So if P then Q. So I'm looking for a if true, then false. So if true, then true, that's true. If true, then false, that's our false statement. If the antecedent is true, but the consequent is false, it makes the whole conditional statement false. If false, then true, that's true. If false, then false, that's true. All right, so for the converse, we're going to take Q, then P. So we're going to go kind of backwards. So if true, then true is okay, that's true. If false, then true, that's true. If true, then false, okay, that's the one that's false. And then if false, then false, that's true. Do you see how I'm using the columns in a different order and therefore getting a different truth value? Okay, so next I'm going to need the not of P and the not of Q so I can use those to get the truth values for the inverse and the converse. So again, not is the easiest one. It just changes all the P values from false to true or true to false. I'm going to do that for both columns P and Q. And now I can do the inverse. The inverse is not if not P, then not Q. So I'm going in this order. If false, then false, that's true. If false, then true, that's true. If the antecedent is false, then the whole thing is true. If true, then false. Okay, that's the only one that has a problem. If the antecedent is true, but the consequent doesn't follow to be also true, then the whole statement is false. If true, then true, that's true. Okay? And one more, I'm going to do the contrapositive. So now I'm going to take if not Q, then not P. So I'm basically going in the opposite order. If false, then false, that's true. If true, then false. Uh-oh, that's the one that's false. If false, then true, that's true because the antecedent is false. If true, then true, that's okay. That's true. Okay, so it's interesting to note which one of these have similar truth values. So the conditional statement has truth values of true, false, true, true. The other one that has the same is the contrapositive. True, false, true, true. So those two are going to have the same truth values. So if they have the same truth values, what can we say about them? We can say that the conditional statement is equivalent. That's the word we want to use. So that's equivalent to the contrapositive. So the converse says true, true, false, true. And the inverse also says true, true, false, true. So those two are actually also equivalent. So the converse statement is equivalent to the inverse statement. So let's show you how this works with actual words. So I have a conditional statement. If you live in Houston, then you live in Texas. So you live in Houston is going to be our P. Then you live in Texas is going to be the Q. So I'm just going to write a little note up here. This conditional is if P, then Q. So the converse would be if Q, then P. So the way I'm going to write that is if you live in Texas, then you live in Houston. Okay, so all I've done is I've taken the P and the Q and reversed them. So the next one, the inverse, is going to be if not P, that implies not Q. So the P is if you live in Houston. So if not P would be if you do not live in Houston, then you do not live in Texas. Okay. All right, and then our next one is going to be the contrapositive. Now the contrapositive says if not Q, then not P. So the Q is you live in Texas, so I need if not Q. So if you do not live in Texas, then not P. So my then, you do not live in Houston. Okay, so which of these statements are equivalent? It turns out that the conditional statement and the contrapositive have the same truth values, and the converse and the inverse have the same truth values. So let's go ahead and read those. The conditional, if you live in Houston, then you live in Texas. So that's a fairly valid statement, right? The last statement, contrapositive, if you do not live in Texas, then you do not live in Houston. So if you don't live in Texas, then you can't also live in Houston. Those two have the same truth values. So if it's going to be true, then the other one's going to also then be true. So let's look at the converse and inverse. If you live in Texas, then you live in Houston. I think there's a couple of counter examples to that, because if you live in Dallas, you live in Texas, but you don't live in Houston. So probably not a good valid statement, but it doesn't really matter at this point. We just need to know what the true values are equal to. So let's look at the inverse. If you do not live in Houston, then you do not live in Texas. That's equivalent of saying if you live in Texas, then you live in Houston. Okay, so we have our equivalent statement. So that wraps up that example.